All right, we're going to look at the third method for solving systems of equations, and that is called the elimination method. And this actually involves a couple of steps, and I've actually combined two things because I think it's just easier if you talk about them in one time rather than try to do it two separate times. Okay, so we're going to use the elimination method to solve systems of linear equations in two variables. So when solving a system of two equations, you can sometimes add or subtract the equations to obtain a new equation with just one variable. Okay, so let me explain to you why this works. If I have a balance scale, so here's my balance. I don't even know how to draw one. Let's start like this. So these are balanced. Okay, and I have a bunch of things here, and I have a bunch of things there. Okay, and they're balanced. And then I have another balance scale, and I've got something there, and I've got a whole bunch of stuff here. Okay, because these are equal and these are equal, I could add these together. And see, these are supposed to be like triangles. And they're going to be balanced. Okay. Because I know that these, I'm taking two equal things and adding them to two equal things. And so I end up with two equal things. Okay. So that's basically how this works. I can take any two equations and add up the left sides and add up the right sides, and whatever I end up with is still going to be equal to each other. By the same token, I can take two equal equations and subtract, find the difference on the left side and the difference on the right side, and they're still going to be equivalent. So that's why this works. Okay. So if I take this equation here, this system of equations, I have 5x minus y equals 12, 3x plus y equals 4. It's usually helpful if you have them written in standard form, okay, because then your variables will line up. Here I have 5x and 3x lined up, and negative y and positive y lined up, and then my constants over here, 12 and 4 lined up, okay? If I look at this, if I were to add these two sides together and these two sides together, I'm still going to be equal. But look what happens. 5x plus 3x gives me 8x. Negative y plus y gives me 0y. So the y's canceled out, and I'm left with this, and I can solve for x is equal to 2. I then plug it back in. So I'm going to use substitution now. I'm going to plug it back into either one of these equations. I'm going to solve for 5. So if I plug it back into the first one, I'd have 5 times 2 minus y equals 12. 10 minus y equals 12. Negative y equals 2, so y is equal to negative 2. Let's quickly check. If I plug in 2, this gives me 10. 10 minus negative 2 is the same as 10 plus 2, which is 12, so that works. If I plug them in here, 3 times 2 is 6, minus 2 is 4. So my solution then is 2, negative 2. Okay, so what I did was I kind of saved myself some steps. I still use substitution here, but if I were to do the substitution method, I would have to take one of these and I have to rearrange it and get y equals or x equals. Okay, here I kind of was able to skip that step because I said, if I add these together, those y's are going to cancel out. Okay, let's look at this one. Here we have 6c plus 7d equals negative 15, and 6c minus 2d equals 12. If I add these together, I'm going to end up with 12c plus 5d equals negative 3. So I won't have eliminated anything. This method is called elimination. We want to try to eliminate something. So if I look at this and say, well, if I subtract this equation from this equation, those 6c's will cancel out. So in order to subtract, I go through and I change all these signs, okay? So if I'm subtracting 6c, this is minus 6c. If I'm subtracting a negative 2d, it's the same as adding a positive 2d. If I'm subtracting 12, it's the same as adding a negative 12. Okay, and then I go through and I simplify this. So 6c minus 6d is this 0. 7d plus 2d is 9d. Negative 15 minus negative 12 is going to be negative 27. And I can solve for d, which is going to be negative 3. I can then plug it back in. And again, I can plug it into either one of the equations. If I plug it in here, let's see, I'll have 6c plus 7 times negative 3 equals negative 15. 6c minus 21 equals negative 15. 6c equals 7, okay, because 21 minus 15 would be 7, I think. Let's check this out. 15 negative plus 21. No, I'm lying to you. It's 6. Crazy. So C would be equal to 1. Okay, let's double check. We've got C is equal to 1, D is equal to -3. So I would have 6 minus 21. Okay, 6 minus 21, which is -15. So that one works. Let me go back and cross out these. So I have my original. 6, this would be plus 6. -2 times -3 is positive 6. So 6 plus 6 is 12. So that one works. So then my ordered pair, now here's where you have to think. Ordered pairs are always going to be in alphabetical order. So C is first, so that's 1. D is second, which is -3. If this was a word problem, we don't worry about alphabetical order, but this is not a word problem, so we have to look at our variables and decide which would come first alphabetically, and that's going to be our X. Okay, so those are elimination. You start by eliminating one of the variables, then you use substitution to find the other, and then you go back and check. Okay. The two equations in a system don't always have the same or opposite coefficients for one of their terms. So in this case, these both had opposite coefficients of 1 and -1. These two had the same coefficient of 6, so we were able to easily manipulate those, okay? And what they're saying is sometimes it doesn't work that way, okay? You may need to create an equivalent equation for one or both of the equations before you can eliminate one of the variables. Equivalent equations are created by multiplying the entire equation with a number. You can multiply each equation by a different number, okay? So this is where it gets a little bit trickier. I look at these and I say, well, none of my variables have either the same or opposite coefficients, okay? However, if I look at this, I say, well, 5 is a factor of 10, and here my 5 is negative and my 10 is positive. If I were to multiply this -5 times 2, that would give me a -10 and a +10, and those will eliminate. Well, I can't just multiply the -5 times 2. I have to multiply the entire equation by 2. Okay, I'm just making an equivalent equation. So that's going to give me 8x minus 10y equals 46. Make sure you multiply everything in that equation. Okay, and then I still have this one. Now I can add these two equations together, okay, and the y's will cancel out. So I have 11x is equal to 77, so x is equal to 7. Okay, I can plug it back in anywhere. I'm going to plug it in here. So I'll have 3 times 7 plus 10y equals 31. So 21 plus 10y equals 31. 10y equals 10, so y is equal to 1. So let's do a quick check. 28 minus 5 is 23, so that one works. And again, I used my original equation. I didn't use this one. And this would be 21 plus 10 equals 31, so that works. So my solutions then are 7, 1. Okay, and make sure you put them as an ordered pair in the correct order. Okay, let's look at example 3. Okay, so that last example, example 2, we only had to multiply one equation. Okay, so let's look at this. Here's a situation where we're going to have to multiply both equations. Okay, 3 is not a factor of 5, 4 is not a factor of 9. So we can look at this and we say, well, I could multiply this equation by 5 and this equation by 3. That would give us 15a for both of these. I could multiply this equation. This would have to end up being 4 and 9, which 9 is kind of big. So I'm going to multiply this one by 5 and this one by 3. Okay, and it's easier if I just make one of them negative. So let's go ahead and make this one negative, and then I can just add, and they'll be opposites, and so they'll disappear. So let me explain what I'm doing here. So I'm going to distribute. So this is going to be 15a plus 20b equals 10. This one is going to be negative 15a. So when I add these, they disappear. Minus 27b equals -3. So basically, I'm adding. So 15 and -15 is 0. 20 and -27 is -7b. And that equals equal to 7. Divide both sides by -7. So b is equal to 1. I can plug that into any of these. I'll plug it into the first one just because. So 3a plus 4 times 1 equals 2. 3a plus 4 equals 2. 3a equals -2. A is equal to -2/3. And you might look at that and go, ooh, wait a minute, there's a fraction there. And it could indicate that something's wrong. And it is wrong because I didn't do a negative there. So let's try this again. Okay, it's those signs that get us every time. All right, so this becomes 3a minus 4. Now, that doesn't mean that you won't have a fraction ever. It just means that, let me just go back and check because we don't like having fractions. So this becomes 3a equals 6. This makes more sense. A is equal to 2. That looks friendlier. So let's double check. So I would have 3 times 2, which is 6. 6 minus 4 is 2, so that one works. And 10 minus 9 is 1, so that one works. So my solution then is 2, -1. Okay, make sure you get that negative there. All right, let's look at example 4. Okay, now they give us fractions, which we don't like. We don't like fractions. They scare us. All right, so if I multiply this equation by 3, it's going to get rid of my fraction, and I'm going to end up with 5x plus 3y equals 7. If I multiply this equation by 4, it's going to get rid of my fractions. I'm going to have 4x plus y equals 14. So I want to try to do this all in one step. So I'm just going to write these very lightly. This would give me 5x plus 3y equals 21. This would give me 4x plus y equals 14. Okay, if I multiply this by something that's going to give me a -3y, those will cancel out. So I'm multiplying by 4. So 4 times -3 is -12. So here's what I'm going to do. I'm going to do 3 times this equation. So 5x over 3 plus y equals 7. And I'm going to do -12 times this equation. And you're looking at me going, what? You can do this in 2 steps if you want. I just don't like doing extra steps if I don't have to. So this will give me 5x plus 3y equals 21. This will give me -12x minus 3y equals -42. Okay, you could have done it in 2 steps. You could have gone through it and gotten rid of the fractions first and then multiplied this equation by -3. I just did it together in one step. So this gives me -7x. Those cancel out. This gives me -21. So x is equal to +3. So I'm going to plug it into this first one just because it'll eliminate, this 3 will eliminate the fraction here. So this becomes 5 plus y equals 7. So y is equal to 2. So 3 and 2 look pretty good. So let's double check them. Okay. 5 times 3 is 15 divided by 3 is 5. 5 plus 2 is 7. So that one works. Here we would have 3 plus 2/4, which is 1/2. So that'd be 3.5 is the same as 7/2. That one's true. So my solution then is 3, 2. Okay. And let's look at the try this. Solve using the elimination method. So if I look at this one, I can immediately see I have a -3b and a +3b. So those are going to cancel out. I'm just going to add. So I get 3a. This will give me 0 equals 15. So a is equal to 5. I'm going to plug it into the first one. So 5 minus 3b equals -1. -3b equals -6. B is equal to 2. So let's double check. 5 minus 6 is -1. 10 plus 6 is 16. So I have 5, 2. I know that the 5 is first because A comes before B in the alphabet. All right, number 2, looking at them, I don't see anything that I can immediately do. So I notice that the T's already have opposite signs, so I'm going to focus on the T's. So I'm going to multiply this equation by 2 and this equation by 5. So that's going to give me 8s minus 10t equals 6. And here I'll have 15s plus 10t equals -75. Let me just double check that. 15 times 5, yes, 75. So this is going to give me a 23s is equal to -69. So s is equal to -3. That worked out lovely. And if I plug that in, I'll have 4 times -3 minus 5t equals 3. I'm just plugging into this original first one. I don't plug it into these. So I have -12 minus 5t equals 3. -5t equals 15. So t is equal to -3. So let's check. So they're both -3. So that would give me -12 plus 15 equals 3, and that is correct. This would give me -9 plus -6 equals -15, and that is correct. So S comes before T. In this case, it doesn't matter since they're both the same. And there is my solution.